All right, back to bore the heck out of you again. So we were talking about covariance with multiple assets and how that gets quite messy. And this is where we actually use some of the built-in tools in Excel, particularly Solver. Um, and we use that to optimize what we call the Sharpe ratio. This is kind of the Sharpe magic of the Sharpe-Markowitz portfolio theory. So what the Sharpe ratio is the let's get rid of this guy here. You have in the market a risk-free asset, be that a government bond, or in this case, we have a proxy for our risk-free asset here. It's essentially risk-free when we've done the analysis on it. You look over a couple of years, it grows $2. Basically, with inflation, it's essentially a 0% asset. There's no risk. There's very, very, very little return on this, such that if you were to put all of your money in this money market ETF, it would do virtually nothing. It wouldn't grow that much, but you also are essentially guaranteed a very, very small return. It is risk-free. Google, Ford, Nike, Shell, American Steel, Sturm Ruger, on the other hand, are all risky to some degree. They give you a return profile, an expected return, which is essentially the mean of all of these data points. That's what you can expect at the end of it, but they give you that in relation to the standard deviation. How likely are they to deviate from that? How much in how many standard deviations? So the value of an asset isn't just its expected return over its variance. It's its expected return minus a guaranteed safe return over its variance. Essentially, how worth it is it to take the risk to buy Google when you know it's got a high variance versus chucking all your money in this market ETF? So yeah, that's the Sharpe ratio of an asset. Essentially, it would be the expected return, or sorry, the excess return. Because here are historical prices. Here we have our returns, and then here we calculate our excess returns. This is this same table here with essentially everything minus this other return. That's how much you can make over and above if you had just put into the money market ETF. Yeah, so from there, we're going to we get our expected returns globally for those assets. We look at our standard deviation. We could probably use a couple more significant digits right there because they aren't that nice and round in real life. They are quite a bit messier, and I like to see a bit of a mess sometimes. Yeah, there we go. Quite a bit messier. And that gives us our Sharpe ratio here. And essentially, our Sharpe ratio helps us determine the value of that asset, how good that is versus essentially doing nothing. And when we look at you can do an aggregate Sharpe ratio for the entire portfolio. So when we look at our result set here, and I should probably show you the variance covariance matrix we made here. You see, so this line here, the diagonal where it's the covariance of Shell with Shell, Nike with Nike, yada, yada, yada. That's essentially the variance, how it relates to itself. And then you have the covariance for Google and all of the other ones, Ford and all of the other ones, et cetera, et cetera. So we're going to be using that in kind of an automated fashion because I don't really know how the mechanics work. I'm using the black box solver here to get our result set here. And basically what we've done is originally we gave all of these stocks here equal weight. We gave their average return, and that's their excess return, essentially the average of the excess returns. And let's get a couple more significant digits there because they are non-zero as well. Because if they were zero, you wouldn't get anything. And here we see that you can expect to lose money with Ford. So what we did was we took these assets, these 6 assets here, and then we assigned an equal weighting to each of them. And this is just a little constraint check here. Essentially, yeah, they all had an equal weighting. And then we looked at the portfolio expected return, which was the aggregate of the return, which was in Sharpe Markowitz here, portfolio return variance, very easy to calculate. Then we looked at the the portfolio return. There's the total variance. That's the standard deviation, which is the root of the variance. And then we have our Sharpe index calculated, which is our entire profile for our portfolio of equal weights minus the expected returns from our money market ETF over the standard deviation here of the entire portfolio, gives us our Sharpe ratio and tells us essentially how efficient it is. And what we've done here with the solver is we've said, okay, we want you to maximize the Sharpe ratio here. So we've maxed that out here, because that's our portfolio return. Max that out by adjusting these inputs here. Now, where it is a black box, I'm not exactly sure how it works. And from what I understand, there are some numerical accuracy issues with this tool versus, say, a similar thing in R. But I'm afraid I'm not technical enough to evaluate that. And this is just kind of a proof of concept sort of thing. So when we say increase your Sharpe ratio as best as possible, do it by reallocating these weights. And it's done that. So it's actually entirely deallocated Ford, because we can see the average return of Ford is negative. So get the hell out of Ford. Or does it get the hell out of Dodge? And then, of course, Google has a great return for its risk profile, so we heavily weight that. And I mean, Shell, its petrochemicals, they're just fantastic. Not for the earth, but for returns in general. They actually hire people to murder other people to ensure the returns. So they are a great investment, not ethically, but just monetarily. So basically, that gives us our ratio of how to invest in this particular portfolio of assets. That'll give us a return profile. And we've plotted that out here with a couple of other points here. That's our minimum risk. Basically, we've optimized for what is in this case the lowest standard deviation, which gives us our minimum risk, and that you weighted it such that we have this data point here. That is our original starting point. That's our equal weight, where we had everything equally weighted amongst all of those, and we say go for it. What does that give us? That's our max Sharpe ratio. This is our current Sharpe ratio here, and that tells us what our best risk return profile is for all of these assets in their current allocation. And then this is the max possible return we could have, which would be the maximum risk we could also have. It's significantly higher. It's almost 3 times higher return, but it's 5 times more risk. So obviously we don't have an appetite for that risk. We're probably going to take somewhere along the max Sharpe. Now, the interesting thing about this entire thing is when you have this pool of assets that you've done this calculation for, and you can say what your efficient frontier is here. This efficient frontier has a risk profile that bottoms out right down here. Well, what if the appetite for the client's risk is actually below there? So the great thing is, this is along this line. It's a given ratio of assets that we've picked. That ratio holds, and that in and of itself is a new asset with its own profile. It's got the identity of being a new asset. It's a collateralized asset, but it is an entirely new entity, and you can have that entire entity in proportion to another entity. And the immediate entity you can have it in proportion to, and this is really cool, is you can have it in proportion to your risk-free asset. So our money market ETF, which essentially doesn't grow, you can weight this entire portfolio, and let's say we have an appetite for this much risk, or we already have this portfolio at our max Sharpe rate. We have it at these ratios. We can take that as a total proportion of this plus the other asset, and this just becomes the 2 asset one here. Right here, where you can get our new portfolio variance by looking at the zero risk And because the zero risk is essentially zero standard deviation, you basically just cut that entire section out, which is just nice and easy. But you can basically find what they call the tangential portfolio, because where you decide your risk portion is actually comes up along the line as the tangent of your portfolio that you've picked along that efficient front. So you can have, in proportion to that, a risk-free asset, and you can decide how to allocate those to get an even different new asset, which is derived from those other two in proportion, and gives you the desired risk-return profile. But the interesting thing about that, if I can get even geekier on this one, is you can use that to determine, because you might have a total max amount of money, whether or not you should buy or sell your total portfolio allocations. You can actually sell as a short sell. They have what they call lending and borrowing portfolios, where you would borrow to invest heavier into the portfolio, or you would lend, allowing people to short your portfolio out so that you can use that capital to buy more of your risk-free asset and then hedge against your portfolio that you currently have. So yeah, this is it's not exactly an interactive what if analysis. It is actually very brittle, which is unfortunate, because what I'd like to do is ideally have something where I can plug stuff in and it'll start to move for me. So I'm sort of moving in that direction. There are a lot of bugs to work out there, and this is kind of the Excel prototype. But yeah, that is my analytic bit. And I should warn you that I am not a statistician. I am not necessarily a data scientist. I am not a financier of any kind. So there are some things I don't exactly have a perfect handle on that I have to do a lot more research on. But this is kind of a proof of concept of doing the Sharpe-Markowitz modern portfolio theory for allocation of assets in Excel. This can be expanded in some interesting ways. I was not responsible for the variance covariance, nor was I responsible for the analysis tool, the solver that actually gave me my answers. Those are essentially two black boxes to me that I'm able to chain together and say, okay, do that thing. But ultimately, the offshoot of this being a prototype, is that I would have a tool that I could say, oh, pick these stocks in a given, scrape the last 3 years of these stocks weeklies and tell me how much I should buy if I have an appetite for so much risk. And yeah, the groundwork's there. It all sort of functions, albeit quite brittly. So yeah, that was my applied analytics project. I hope you've enjoyed it. I hope I haven't left anything out, and I hope I haven't bored you to tears. Thanks so much.